The 20th element on the periodic table of elements is calcium. This is Norris Teaches Science with me, Mr. Norris, another physical science edition video. Today we're going to talk about reaction basics. So we're going to talk about in the next coming videos about different compounds interacting with each other. So the goal of this video is I can identify the different parts of a reaction and count atoms in a compound. So what is a chemical reaction? It's when two or more elements chemically combine to form a new substance. It's a chemical change. So new substances are going to form during chemical reactions. Now, what are chemical equations? This is how we represent the chemical reaction on paper. And we're going to use there's two parts to a chemical equation: the reactants and the products. Right? So let's talk about them. Reactants and products. And we're going to look at this reaction here. It's not really true how it would work, but C plus O2 yielding CO2. Carbon plus oxygen yielding carbon dioxide. The arrow divides the equation in half. This arrow divides this equation in half. So I'm going to use it to divide the PowerPoint in half. On the left side of the arrow, the C and the O2 are known as the reactants. These are the things that will undergo the change. They'll be combined together, or they could be broken apart. Something's going to happen to these substances on the left side of the arrow. CO2 is known as the product or products, depending on how many there are. These are the new substances or substance that forms during the reaction. It's always to the right of the arrow. Right of the arrow. So CO2, carbon dioxide, is the product. So let's look here. I'm going to get the highlighter out, and I'm going to use purple here. I'm going to highlight the reactants in each equation in purple. The reactants are anything to the left of the arrow. So in this first one is this stuff right here. In the second equation, that's KClO3. In the third equation, it's HCl and it's NaOH. And the last one, N2H4 and O2 are all the reactants. Now I'm going to change the highlighter to blue, and anything that's a product, I'm going to highlight in blue. So in the first equation, CuO is a product. The second one, KCl and O2 are products. These numbers here indicate how many there are of there, and they're going to come in factor in a moment when you do something else. The third equation, NaCl and H2O, are all products. So N2 and H2O, this last one, they're both products of the equation. Remember, the arrow divides the equation in half. The arrow divides the equation in half. Now, some equations, some reactions, some equations, you'll have words like heat or light or something like that. Endothermic reactions, these are reactions that absorb energy from the surroundings. So if it's going to be endothermic, this is going to be a reactant. You're going to have like heat or energy or light as a reactant. And usually when this happens, the surrounding does get cooler. And exothermic reactions, you're going to have heat, energy, light as a product. The reason why it's a product, because it's going to release it to the surroundings. And if you release it to the surroundings will become warmer. Now, some signs that a reaction is taking place, you've got production of a gas. You can see that over here. Fizzing, bubbling. You have formation of a precipitate. It's this insoluble solid when two liquids are combined. You got energy release, that like light with a glow stick, or heat. Some reactions, heat is released in it. Um, and a color change. Usually this is we're not talking like food color change. We're talking like two clear liquids suddenly producing a pink liquid. That would be a color change there. Now, when we talk about compounds and reactions, we got to talk about counting atoms. And so those big numbers you see, so say I have 3H2O, this 3 here is known as a coefficient. It's multiplied to everything behind it. Subscripts like this 2 would only just go to the H. All right, and we're going to do some practice with this. So we got this first one. We need to count the atoms, which means we need to count how many of each atom there are for each element, and then how many total atoms there are. So in this first one, the first thing you do, you look at what symbols you have. The first symbol I see is C, and I do C equals, and then I see O, O equals. There's no more symbols. So the last thing I usually write T equals, and this T represents total. All right. Then we look at the numbers that are in the compound. This 2 here only goes to the O. And it's good if you actually draw your arrows to know where all the numbers are going. The big 2 in the front, this big 2 is going to go to the C, and it's going to go to the O. Now my question is there a number right here? If you say no, then you're wrong. There is a number. It's 1. Remember, chemists don't write the number 1. They're just implied. All right, so for the C, we have a 1 going to it, and we have a 2 going to it. We multiply these numbers. So 2 times 1 equals 2. This O, we have a 2 going to it, and we have another 2 going to it. So we multiply those numbers. 2 times 2 equals 4. All right. Now to get the total, we add up these numbers that we just got. We add the 2 and we add the 4 together, and we get 6. All right. Let's do number 2 together. All right. The first symbol I see is Mg. Mg equals. Next symbol I see is O equals. And the next symbol I see is H equals. And then I don't see any more symbols, so I have a T equals for total. We don't have a number in the front, so it's implied 1, so we don't have to worry about that. There's no number next to Mg, so it's implied 1. No number next to O, implied 1, but we have this 2 here. The 2 is attached to the parentheses. If there's a number attached to a parenthesis, it goes to everything inside the parentheses. So this 2 is going to go to the H, and it's going to go to the O. All right, so we have, looking at Mg, nothing's going to Mg, so it's a 1. There's a 2 going to the O, and it has a 1 there, so 2 times 1 is 2. The H has a 2 going to it, and it's implied 1. 2 times 1 is 2. To get total, we do 2 plus 2 plus 1. We should get 5. All right, pause this video real quick. I want you to try number 3 on your own. I'm going to count to 5 for you to pause before I begin. 5, 4, 3, 2, 1. All right, let's do this. The first symbol I see is Ca. Ca equals. Next one I see is N equals. Then I see O equals. I don't see any more symbols, so T equals. Next thing, let's figure out where all these numbers are going. This 3 in the front is going to go Ca, it's going to go N, and it's going to go to the O. This 3 right here is only attached to the 3, so it's going to go to the O only. And this 2 here is attached to the parentheses, so it's going to go to everything in the parentheses, so the O, and it's going to go to the N. All right, now let's figure it out. Ca. C has a 3 going to it and an implied 1. 3 times 1 is 3. The N, it's got a 3 going to it, it's got a 1 applied, and then it's got a 2 going to it. So we got to multiply all three numbers together. 3 times 1 is 3, times 2 is 6. I know, it looks complicated. Now, let's look at O for oxygen. First number I see going to it is a 3 from the front. Then I see another 3 from a subscript going to it. And then I see a 2 going to it as well from outside the parentheses. So now we have to multiply all three numbers together. 3 times 3 is 9, times 2 is 18. Now to get the total, we do 3 plus 6 plus 18, and you would get 27 total atoms. Is that what you got? All right, number 4 is a trick. There's a trick here. We're going to write our symbols first. I see an N equals, then an H equals. The next thing I see is an O equals. Then there comes another H. You don't write H again. H is already there. So that's all the symbols. Total equals. All right, at the front, there's nothing. So it's implied 1. All these empty spots are implied 1. The only number we need to worry about is 4. 4 goes directly behind it to the H. All right, we're going to do H's last. We're going to do the easy ones first. N, there's no number going to it. It's a 1. O, there's no number going to it. It's a 1. This is where it gets difficult. At this H, there's 4. At this H, there's 1. When there's symbols in multiple spots, you figure out how many atoms there are at each spot. Then you add those numbers together. So there are 5 H's. Then to get the total, we add the numbers up and we get 7. That's a little basics about reactions. The counting atoms is going to come back in when we do the next video on balancing chemical equations. So make sure you go practice that. I hope you learned something today. And like always, I'm Mr. Norris and I'm out for this video.